All right, so apologies, because the only drones in this presentation will be me droning on about culverts. So I do want to talk, though, about an important document that we produced for NCHRP. This is NCHRP Project 1426 that I'm going to be talking about. This is the Culvert and Storm Drain System Inspection Manual. So this was long overdue. This replaces a 1986 FHWA Culvert Inspection Manual. So it's been 30 years since the original document was updated. Like I said, it's long overdue. There's been a lot of advancements in culvert, especially materials related. Plastics weren't covered in there. Timber materials weren't covered, so we've added those to this document. We've also completely overhauled the manual. It represents essentially a brand new document. So part of our task after we completed this document was to get this in a format for AASHTO publication and also to bring some awareness of the document. So two things I want to do today: one, bring some awareness to this document, and two, introduce the content so you're aware of what's in there. So we'll start with a little background and introduction. So the project, like I said, is NCHRP 1426. We completed this in March of 2016. The objective of this research was to develop an inspection manual for assessing the in-service condition of culverts and storm drain systems. So I'll leave the storm drain out for today, and we'll focus on culverts. So two things we really wanted to accomplish is to have a way to rate these, bring the ratings of culverts more in line with bridges, bring some parity between bridge element inspection, NBIS program, and inspection of culverts. And also to make economical use of owner resources. The culverts are, in fact, the little brother of bridges. They don't get as much attention as the bridge, primarily because they're thought of as having a lower investment. But when you think about the fact that culverts represent more than 10 to 1, and in some areas 20 to 1, they outnumber bridges. When you think about them as an asset as a whole, it brings their value of the entire inventory more in line with bridges. So they do deserve attention. Consequence of failure can be drastic in many cases. So inspection is important, not only for the safety of the traveling public, but to make good use of our resources. The final deliverable for this project was the Culvert and Storm Drain System Inspection Manual. So at the end, I'll talk a little bit about where that stands and when you can expect to see that product. We also produced a final report, which is available online. That documents the research. Our oversight panel for this project included members of the DOT, FHWA, manufacturers of culvert and culvert systems, industry representatives, engineers, and academia. So I do want to give a quick shout out to the oversight panel for the valuable feedback they provided during this research process. So like I mentioned, two products, the Culvert and Storm Drain System Manual, that's the cover there. We also produced a final report which kind of documents the research side of this, what went into the research, how do we develop some of the rating systems. That is available for free online. So when you see this, incidentally, that cover will be blue. When I made that cover, I didn't realize that AASHTO bridge-related documents need to have blue covers. So that's going to change, but otherwise it'll be very similar. Okay, so I want to preview a lot of the content, and I'm going to go fast through this because I got a lot of content here. You'll see a lot of words on the slide, but I do want to at least present it to you, and this presentation will be available to you also if you want to look into it a little more. So organization of the manual. I'm going to step through section by section, focus primarily on section 4, which is the condition rating system, but we've got 5 sections in this manual. Section 1 is an introduction. Section 2 discusses the design and performance characteristics. That goes hand in hand with Appendix A, which is the structural shapes, material system components. So Appendix A is really a precursor, if you will, to Section 2. That presents more of the basic stuffs for individuals that are new to culverts, culvert systems. They want to know What are the common materials, common shapes, and that kind of thing. The content of Section 2 itself, it deals more with some of the background of the engineering, the hydraulic design, that kind of thing, and more related to what is necessary for an inspector to understand in order for them to interpret some of the distress they're seeing in the field. Section 3 is the inspection procedure. This outlines good practices, best practices for developing an inspection program, how that should play out, flow charts, et cetera, discussion on preparation and planning, QA/QC. Section 4 is really the meat of the document, though. That's the condition rating system. We've also got an appendix that goes hand in hand with Section 4 as well. Appendix B is the catalog of distress conditions. This was an important addition to this document. This provides a visual comparator for the ratings tables. So the ratings tables are set up with individual distress categories. Now we have an appendix that has photos from actual field investigations that show what each of those distress conditions should look like. So this is a very powerful tool that we think will be relied on heavily for inspectors in the field in order to understand. And this also instills some repeatability among inspectors too. So if you've got two inspectors looking at the same culvert separated by chronological inspections, you can expect that they will come up with a similar rating. So that is important. Repeatability is obviously important in collecting this data. Section 5 is a little bit on asset management. This is kind of an add-on to the document to talk about how culverts can be incorporated into asset management programs. So Section 1 is the introduction. So Section 1 contains some information on the need for standardized inspections, the need to have an inspection program, provides some of the manual objectives, identifies the intended audience, and instructs users on the organization of the manual. And of course, as an introduction, we include some of the obligatory disaster photos to call attention to the fact that there can be some catastrophic consequences of culvert failures. Section 2, as I mentioned, includes some of the engineering background that's necessary for an inspector to understand in order for them to interpret some of the field data that they're collecting. So here we've included hydraulic, some of the structural behavior, flexible versus rigid structures. Remember, culverts are buried structures. So there is some soil structure interaction that goes on, so there's a little bit of discussion about how the backfill works with the structure to provide stability. Loads on the culverts and storm drains, we include a little bit of discussion on those and how those loads are distributed through the soil and what kind of consequences overload conditions can have on distress in the culvert. Durability is obviously a concern for some of the materials over a service life, so we've included some mechanisms of corrosion and degradation, discussion of how durability plays into the service life. And finally, some of the basic components of the culvert and storm drain systems are included in Appendix A. So hydraulic requirements, as I discussed. So this is basically a primer on inlet versus outlet control, how the hydraulics of a culvert essentially work, and how some of the distress factors that we're asking culvert inspectors to look for can affect the performance, the hydraulic performance of a culvert. Again, structural behavior, we're talking about flexible, primarily flexible versus rigid, because distress characteristics of the two types will show up differently. So rigid structures rely less on soil structure interaction. They typically, distress in rigid structures tend to show up as cracking, material cracking. Flexible structures, as the name implies, are flexible. So there is some give in the structure, some elasticity. Those are primarily deflection controlled. So there's a different technique for inspecting those. So there's some background and discussion on why there are some differences between the materials. Construction and installation terminology, we're including some background on the construction and how that might relate to some of the distress in the culverts. We're also talking about some of the considerations that may not be obvious during the inspection process, but were accounted for in the construction and installation. Some of those include compaction of the side fill, foundation embedding, the width of the trench, camber in the structure itself, and high groundwater. So the performance characteristics that I mentioned before, we've included some discussion on durability. So for metals, we're talking about corrosion, the different mechanisms of degradation of concrete, and how the environment that the culvert is in plays into that degradation. Degradation of plastics. As I mentioned, we've introduced plastics to this manual now. So we have a discussion on the different degradation mechanisms of plastics, and that includes both HDP and FRP. Abrasion. So for some of these structures, they are susceptible to abrasion, so there's some discussion on that. And again, Appendix A is the background information. It's shapes, the different shapes that culverts come in, the common types of cross-sectional shapes, the different materials that are available for culverts, the components that go in. So this includes the foundations, the head walls, the wing walls, the invert slabs, the aprons, etc. Section 3 is the procedure. So this is all procedural stuff for performing culvert inspections. So we have in this section various subsections that include purpose and scope of inspections, frequency, recommended frequencies of inspecting culverts, preparation and planning, types of inspections, types of entry, inspection team role, and qualifications. So we've provided some recommendations for putting together an inspection team, what that team should look like, and what they should have for qualifications. Various inspection equipment. So the Bridge Inspector's Reference Manual includes a nice list and pictures of equipment necessary for inspecting bridges. We've included something very similar here in this manual as well. So we have the tools that are necessary, various uses of the tools, and how an inspector might use them. So we've divided them into common tools and specialized equipment that might be used to do more in-depth investigation of certain types of distress. Recording the inspection is obviously important. You're collecting a lot of data, so we've got forms and recommendations on how to collect that data and what to do with it. Safety is obviously a concern with inspecting culverts, so there's some discussion on safety, and then quality assurance and quality control. So purpose, obviously we need to assess the condition of the entire culvert and storm drain system. So this includes the barrel, the waterway leading in and out of the culvert, looking for structural issues, material issues, and also service problems. And that would include issues that would be taken care of by maintenance forces as well. So we need to make accurate and repeatable ratings. So one of the focuses on developing these new rating system was to really have a focus on repeatable. So in order to have repeatable measures of distress, we need quantifiable measurements. So all of the measures of distress, each rating is now a very quantifiable and defined level of distress for each of the categories. Scope of inspections ideally should include all culverts in an inventory. However, there are some small diameter culverts in low traffic areas that don't need to be inspected on a regular basis. So that's kind of an agency level decision. However, for inspection frequency, we do have a table of recommendations. So this table is developed with two factors in mind. So inspection frequency is defined in terms of both the size of the structure and also the condition rating. So the size of the structure obviously speaks to the consequence of failure. So larger structures will have a higher consequence of failure, so they should be inspected on a more frequent basis. Alternatively, as a structure starts to degrade, as it shows distress, it should be inspected more frequently in order to capture that point in time where a structure requires structural repair or maintenance, or it's in critical shape and it requires some full engineering support. So types of inspections, you should look familiar to bridge inspectors in the audience. This is straight out of the MBI. developed and adapted, I should say, for culvert inspection. So the focus of the manual is on the routine inspection. So those are the inspections performed on the defined frequency for inspecting the structural health of the culvert. Types of inspections, we've included some discussion on the different types of inspections. So the best inspection is obviously person entry. You get in, hands-on, eyes on the structure. You can look close up. That's not always possible. There are obviously some smaller structures out there that prohibit person entry. So for some of these, non-entry inspection is acceptable, and especially for the shorter length culverts where you can perform most of the inspection from either end. So there's some discussion on how to do that and what's included, the limitations also of that type of inspection. Another type that's used primarily with storm drains is the remote inspection. So this is typically robotics, instrumented with, at a minimum, video capabilities and oftentimes other types of NDT instrumentation. So the inspection team roles and qualifications, this now looks similar to bridge inspection. Training is recommended in terms of understanding what's in the manual, the rating system, so there should be some in-house training. And there's also an advisory on the physical ability required to perform culvert inspections. They're a little more strenuous than bridge inspections. That comes from the fact that to access these culverts, you often have to climb up and down embankments that aren't very conducive to carrying tools, etc. So there are some physical aspects of inspecting culverts. There's also hazards and safety hazards associated with that as well. We've also included forms for recording the inventory record and for inspection data that's collected for each of the types of culverts. Details on the preparation and planning. So obviously a little bit of time spent in the office can save a lot of time out in the field with a well-organized, well-planned inspection procedure. So organization and scheduling is important, review of past inspection data, developing an inspection sequence, so highest priority first, organizing by geographic location, etc. And quality control is really important too. So we've included a framework for what a quality control, quality assurance program should look like for culvert inspection, and some recommendations on Plan Do Check Act PDCA cycle. So that ensures that this is an iterative process. It's an evolutionary process that when you start out, there'll be some kinks that need to be worked out. So that ensures that there's planning meetings that review what worked, what didn't work, what do we need to add, what can we subtract, that kind of thing. Safety is paramount in all of our professions, so it definitely deserves a section in this manual. So what we've done here is basically highlighted some of this. Isn't a safety document per se, but we have highlighted some of the more important safety topics when it comes to culvert inspection. So these include obviously confined space. Most of these culvert inspections will be permit required confined space. Some of the larger, shorter length culverts I understand are being treated as non-permit. But there are other hazards, traffic hazards, for example, drowning hazards. There's deep flowing water under many of these culverts, so there is a drowning and water hazard. Rugged terrain, as I mentioned, clambering up and down the embankments can be steep and dangerous at times, especially when you're carrying heavy tools with you. Animals and insects, yes, those are dangerous in some parts of the country. Poisonous plants, poison ivy, poison oak, etc. And equipment safety, use of the equipment. There's different types of equipment that culvert inspectors will be using. So there's some hazards that are associated with those. Okay, section 4 is the culvert rating system. So this is really the highlight of this document. This is what the inspectors will be relying on, this section. So for this section, what we've done is we've completely overhauled the 1986 manual. So this is a brand new rating system. It's been updated now to a 5-point scale versus the old 10-point scale. And we've gone to more of an element level rating system. So the condition rating system includes the approach roadway, the channel, the embankment, end treatment, and appurtenant structures. So that would be the head wall, wing wall, aprons, concrete footings and invert slabs, the barrel alignment, plastic, concrete, corrugated metal, masonry, and timber barrels. So these are the materials that we're looking at. And by barrel, I mean the actual structure itself. Joints and seams are included. A little bit about storm drain system components. Most of these are proprietary, so there's not a lot of the individual components outlined in this section. But there is some mention of aquatic organism passage as well, and I'll talk about that towards the end. Okay, so here's a preview of the rating system. So this is essentially the makeup of each of the ratings tables. So for the components that I listed on the previous slide, we have an individual table that looks similar to this. So across the top, we have the ratings of 1 through 5, good, fair, poor, critical, and failed. And then down the side, we'll have the individual distress elements that we're asking the culvert inspector to look for. So each of these conditions are associated with a recommended action. So for instance, good condition would be a like new condition, no distress. Obviously, no action is required. Fair, a rating of 2. The structure is starting to show some distress. There no serious structural concerns, but there could be maintenance activity required. So for that, no immediate action is indicated, but perhaps it could indicate more frequent inspection or a requirement for informing maintenance forces of issues such as sedimentation or debris buildup. Poor condition would indicate some structural concerns with the culvert, and that typically requires an additional evaluation or an engineering review to determine if any corrective action is required and what that corrective action would be. Critical is a condition where corrective action is definitely required, and an engineering evaluation typically takes place, and that would be a very poor condition culvert that has the potential to fail in the immediate future, or at least before the next inspection will take place. So as I mentioned before, these are the individual components that we've included ratings tables for: approach roadway, embankment, channel alignment, and protection. So this will also include some on waterway adequacy, end treatments and appurtenant structures, the concrete footings primarily for the 3-sided culverts, barrel alignment, which is more to do with the hydraulics and the joints. Barrel materials that we've included. Now, I mentioned we've added plastics now, so plastics are becoming more popular. HDP is a very popular material for culverts these days. FRP, not quite as popular for culverts, but we do still see a lot of that out there, so it's included under plastics. Concrete, corrugated metal, masonry, and we've also added timber barrels. Joints and seams are included, and then manholes, catch basins, and buried junctions for the storm drains. So in section 4, we've also included some documentation conventions. So this is recommendations on best practices for recording the inspection. So how to record distress severity, how to record the location of the distress, so tips and techniques for that, how to locate joint distress, primarily so another inspector coming in on a follow-up inspection can easily identify the distress that the original inspector was recording. So for the inspection procedure, we've also included a flowchart of recommendations for how an inspection should proceed. And what I want to do is in order to show you what's in section 4, I want to highlight a couple of examples. We'll look at approach roadway. So in the approach roadway section, what we've got is a lot of discussion, a lot of information on what the approach roadway is. So in terms of defining the approach roadway for culvert inspection, we're calling that the span of the culvert plus 20 feet in either direction. So we ask the inspector to examine the approach roadway primarily because this can foretell problems with the culvert underneath. So we look at, for example, cracking in the roadway. And cracking in the roadway, development of potholes, can be an indication of problems with the culvert underneath. And it can be over deflection, or most of the time it's stuff like open joints. So how does this work? What should the inspector look for? We've included graphics and details on what that should look like. We've also asked them to look at the shoulder, so movement in the shoulder, movement in the guardrail can also indicate similar issues. Here's the approach roadway ratings table. So as you saw in the overview table, across the top we have the good, fair, poor, critical, and failed ratings. Then down the side, the individual elements that we're asking the inspector to look at, so pavement, guardrail, shoulders, and then in each of those cells we have what the different distress characteristics should be. So we've tried to put in as much quantitative measure as we can to help make these repeatable from inspector to inspector. All right, so let's look at another example with concrete barrel. Concrete barrel, what we're looking for here primarily is cracking, and this includes longitudinal, circumferential direction, radial offsets in the cracks. Those help distinguish distress severity, spalling, delamination, slabbing, material delamination, and also clogged weep holes. So why are clogged weep holes in there? Weep holes are there to relieve hydrostatic pressure. So if we have clogged weep holes, they're not performing its function. So we could have additional hydraulic loads on the structure that weren't designed for. So that's important. So we've included some background on how some of this distress develops, the kinds of things to look for, the different levels of severity, what distinguishes between fair, poor, and critical. And then we get to the ratings table. So for the ratings table, this is similar to all the previous ratings table. What I want to show is how this works with the appendix. So for example, if we look at cracking in a concrete barrel, what we see is we've got different types of cracking, longitudinal, different crack measurements, width measurements, different crack patterns that we're asking them to look at. So this can be confusing to a new inspector. So what we've included is in the appendix, so now this is a screenshot straight from Appendix B for cracking. So what we have for each of those cells in those ratings tables, we now have these pictures from actual field inspections that illustrate exactly what these different levels of distress should look like. So we feel like this is going to be an important tool for inspectors to rely on. This not only it goes hand in hand with the ratings tables, but it helps show what this should look like in the field. So if there's ever any question on, well, is this a fair condition or is this a poor condition, you can rely on the photographs to help them determine what that rating should be. And again, we've included for fair, poor, critical, and failed. We didn't include photographs for good because that essentially should be self-explanatory. That's a new condition, so no distress. You don't really need to see photos of that. All right, so I did mention there was some discussion of aquatic organism passage. So AOP programs are very specific to the site. So there is not a ratings table for AOP, but what this section does is alert the inspector to understand if there is an AOP program involved with that culvert, and if there is, then that should trigger them to pull that AOP program to understand what it is they need to be looking for. So there is a little background on AOP, but this is not an inspection document specifically for AOP because those are very specific. The last section, Section 5, is asset management. So asset management, this is basically a primer on how to include culvert inspection in an existing asset management program, some reference to the AASHTO Transportation Asset Management Guide, and some best practices for developing an asset management program. All right, so everybody's favorite slide, the last one. Concluding remarks, I just want to again mention that the 1426 final report's available at this website. It's probably easier if you just Google NCHRP 1426 if you want to see it. So this is I will warn you, this is the final report is only the research side. So this is all the background that went into the research. The final document is currently with AASHTO. So AASHTO has control of the document. T13 committee on the SCOBS committee. So you heard Matt Farrer talk about SCOBS. So this is with the T13 committee. Now they're responsible for Culvert. We've received some draft ballot comments from them that we're currently addressing. This will go to ballot and be voted on for the June 2017 meeting. We fully expect that that will go into publication after that meeting. So the current timeline is that the manual will be available sometime by early fall. So you can expect to see that soon.